Hello everyone. So I'm just going to use a bit brighter. A bit more. Oh, it looks a bit brighter. Oh, sorry. Technical issues here. All right, hope this works. So today we're having a look at a new section. This is section 4.6. Oh, this is just not playing ball today, is it? Hopefully this will work. Okay, so section 4.6, and this is going to be the perpendicular distance formula. So the basic idea of this formula is you get some type of line. Okay, that line will be in the form of ax plus by plus c equals 0. So general formula for a line. Okay, and the idea being that you've got a perpendicular line or an imaginary perpendicular line, doesn't really matter if that you actually draw it, to a point x1, y1. That's a distance of d away. And this formula, and I'll write the formula in a second, allows you to either find those points, find that distance, or in rare occasions, if you have enough information, find that equation. It allows you to do other things, but that's the basic idea. That's the basic kind of geometry we're kind of looking at here. So I'll show you the formula anyway. It's the absolute value. So you've seen this being used before, okay, of a times x1 plus b times y1 plus c over, this is the important bit, the square root of a squared plus b squared. Now, you can see the first thing you're probably noticing is this is going to be a positive answer. Of course it is, because we're looking for distance. Okay, and distance always has to be positive. Okay, now, as far as you're concerned, it's going to have to be positive, but yeah. So distance has to be positive. So that's the kind of the main premise of this one. So then we'll do a very simple one where we're just slotting in numbers and see where we go. And then we'll play around with different scenarios where, you know, you might be asked to find other elements of this kind of scenario or different scenarios where this might come into play. Okay, so let's do a very, very simple one then. So let's say we have an equation of 3x minus y minus 2 equal to 0. And let's say we have a point of 1 and minus 4. And we want distance between this line and this point in terms of the perpendicular distance. So what's the first thing to do? Well, first of all, let's identify our A, B, and C. So there's your A. Your B is going to be minus 1, and your C is going to be minus 2. There's your x1, and there's your y1. So we're going to pop them all into the formula. So if you follow me on this one, sorry. Right. So let's slot these all into the formula and see what happens. So we have the absolute value of a times x1. So that's 3 times 1. Okay, plus b times y1. So that's going to be a minus 1 times a minus 4. Plus a c. Okay, now of course you don't have to put the plus and then the minus. You can put the minus, but listen. Multiplied or divided by the square root of a squared plus b squared. Okay, that's going to give me my answer. So get your calculator out. Okay, let's try and do this. That's going to be 3 times 1 is 3, plus 4 is 7. That's 5 on the top. And that's going to be root 10 on the bottom. Okay, now we've done a chapter already on 5 over root 10. That's not a nice way to put it. You should never put the root on the bottom. How do we get the root on the top? We'll multiply top and bottom by the root. Okay, so that's 5 root 10 over 10, which is the same as root 10 over 2. Sorry, root 10 over 2. Okay, looks nicer, it looks neater. Okay, and that's the distance from there to there, assuming, you know, that's the way it looks. Perpendicular distance. Okay, Cool. So now, of course, there are other things you could do then with that. So before we kind of go on, let's just think of some little explorations. If I know this point, okay, and I know the distance from that point to there, then I should be able to at least derive what that point there, intersection point, is, because I could use the square root distance formula. I'd have two unknowns, and then you'd solve those two unknowns, and only one of them would be substitutable into this equation. So we'll come across them at a later stage, but that's the kind of basic idea of them. Okay, so let's try another one then. Oh, here's a nice idea. What happens if you want to find the distance between two parallel lines? Okay, so I'm going to give it two parallel lines and we'll have a look at it. Now, if you notice, and notice carefully, they're the same because the slopes have to be the same. They can be different, so you're just shifting the thing up and down the page. Okay, so how are we going to do this? Right, well, let's just think of the logic of it. If I could find any point on here, any point at all, okay, then I could use this to that point. So in other words, if I find a point here on this line, then any line drawn to it that's perpendicular, I can use the formula and then find the distance between those 2 points. Okay, so let's find a point on this line. Okay, so how do you find a point on a line when you don't have any points? Well, let's use the X and Y intercepts. And I can see it's going to have an X and Y intercept, so let's do that. So how do I find the X axis intercept? I let Y equal to 0. Okay, simple as that. Let Y equal to 0. And then how do I find the Y-axis intercept? Let X equal 0. Okay, you can pick either one. We just want 1 point. We don't need both points. We just need one of them. So I'm just going to get the Y-intercept. Okay, so let X equal to 0. 3 times 0 minus 4Y plus 12 equals 0. Minus 4Y is equal to minus 12Y is equal to 3. So 0 and 3 is definitely a point on this line. Okay, so that's all I need. So I'm going to call that one 0 and 3. Now I have a point. So I have 0 and 3. That's my x1, y1. And I have this equation, 3x minus 4y minus 1. That's your A, B, and your C. And we're going to pop them into our formula. So absolute value. Well, let's do the easy bit first. We know it's going to be the square root of A squared plus B squared, which is going to be 5. But anyway, you can see that there. It's 9 plus 16 is 25. Root 25 is 5. But let's do the other bit. Okay, the hard bit. We're going to have A times x1 plus B times y1 plus C equal 0. So that's minus 12 minus 1. That's minus 13, but we're looking at absolute value. So that's 13 over root 25, which is 5. That's the distance between 0 and 3 and that line. So it's also the distance, because they're parallel, between any 2 points on either of the lines. Okay. So again, there's another nice one to kind of have a look at. You know, you can see that this question is very accessible. It's a very accessible question. Unlike a lot of the questions that we do, which can be a bit tricksy, this one is actually quite accessible as a question. Now, we're going to have a go at another one. So what we're going to have a look at is one equation. So here we have an equation, and I'm going to give you 2 sets of points. And the question is, and this is our hypothetical, okay? Let's assume that this is this line, and I'm just have to draw on it here. My question to you is, are both of these on the same side, or is it a case, if I drew the line again, that they're on opposite sides? Okay, so if they're on the same side, this is very important. We're going to do the same perpendicular equation again that we've been just using for the previous two parts of this video. However, this time we're not going to get the absolute values off the top. We're just going to let it rip for whatever it is. And it's a test. And the test is very simple. If both, when you put them into the formula, come out as positive distances, then they're on the same side. And if one's positive and one's negative, they're on opposite side. Now, it doesn't tell you which side they're on, just that they're on opposite sides. So listen, I'll go through it and you'll see what I'm talking about when we get into it. So we're going to deal with this little pair first. We're going to deal with, well, listen, these are always going to be A, B, and C. Okay, so we're going to deal with this pair first, x1, y1. We'll deal with this pair first, okay, because it's probably the easiest one to do. Okay, A times x1, so 5 times 5. You notice I haven't put in the absolute values. We're not going to bother on this time. Everything else is going to be the same, plus b times y1, minus 4 times minus 2, plus c. Not going to bother putting the plus and then the minus 30, all over a squared plus b squared, and the root of that, which is going to be 5 squared plus minus 4 squared. So we're just going to work out this answer, and then we're going to park it, and we're going to do the same thing to this one, and then we're going to check whether both of them are the same. Okay? So that's the key. Let's have a look. Right. Sorry about that. Fix that in the editing, as the man says. So we're going to work out this one. So what do we got? 5 5s are 25 minus 8 minus 30. Sorry, 25 plus 8, 33 minus 30. That's 3 on the top, over root 25 and 16 is 41. And that's positive. Okay, so we'll park that one anyway. It's a positive answer. Okay, we're going to do the same thing again now, but we're going to use this set, okay, with these numbers. So what we've got, A times x1 plus b times x2 plus c over, what do we got here? The square root 5 squared plus minus 4 squared. So the same thing again, you're going to get root 41 on the bottom. What about on the top? We've got 15 plus, that's 27, that's minus 3. Aha, negative. So same distance apart, but opposite signs. What does that mean? It means that they're on opposite sides. The perpendicular distances are opposite sides, the points are on opposite sides of the line. Okay, so that's the trick with those ones. So hope that kind of makes sense to you. It's a little test, really. It's a kind of a litmus test of whether or not things are on one side or another. Handy little thing to know. Okay, and again, a little visualization always helps. Right, the last one we're going to have a look at. No, here's a tough one. Okay. Let's say you have a hypothetical line which is parallel to this line. And it has a distance of 3 units from it to the other parallel line. So this is our line. So I'm just going to draw it here. And then there's another parallel line here. And all I know is the distance is 3 units. Okay. Could we figure it out? Well, like, we know something already about it, don't we? We know that if it's parallel, it's going to have this 3x minus 4y. But the question is, what other number is it going to have? Okay. That is exactly 3 away. And that's the key. We could make up any amount, but which ones are exactly 3 away? Okay, for example, 3x minus 4y minus 2, that'd be okay. Minus 8 would be okay. But you know, which ones are exactly 3 away? Okay, so no matter what line it is, it's always going to have this form, isn't it? Okay, where this is just some constant. Okay, it's always going to have that form. Okay, so what we need to do is, well, we need to figure out, like before, a point on this line that we can use in the formula with the fact that we know the answer is 3 to generate what k's would possibly work. Okay, so in order to find a point on this line, well, we'll do our usual. I will do the let y or let x equal to 0, solve for y. What are we looking at here? Minus 4y is equal to 1, y is equal to minus a quarter. So a point on that line is for sure 0 and minus a quarter. So that's going to be our x1, y1. Okay, so the distance from 0 and minus a quarter, x1, y1, to 3x minus 4y plus k equal to 0, the distance is 3. So that's the answer to our formula. So let's pop everything in that we know. Absolute value, that's A, B, and C. A times x1 minus B times x2. I think they designed these to make those kind of weird things. Plus C all over the square root of A squared plus B squared. And that answer has to be equal to 3. Okay, so 3 times 0 is 0. We know the bottom of this fraction is 5. It's done that one before. 9 plus 16 is 25. Square root of 25 is 5. So 3 times 0 is 0. That's a minus 1. Sorry, that's a minus 4 times a minus quarter. That's a plus 1. So we have k plus 1. An absolute value of that is equal to 3. Now, we've done these before, haven't we, lads? Okay. So we've done absolute values before a million times. Okay. So let's try and think of this one then. Well, there's a couple of different ways we could do it. We could just get rid of the absolute value. I'm just going to move it slightly over here. Okay, I'll do it here. You can get rid of the absolute value if you want, and then just decide, well, this could be a plus version or the minus version of 3, and then solve for both versions. Okay, or you could square both. You want to cross multiply and then square both sides and get a quadratic and solve it like you've done before a million times. Okay, it's probably easier because you just got this. So let's go with the, you know, some number over 5. 5 divided by some number gives you a plus 3, and 5 divided by some number gives you a minus 3. Okay. Well, let's think. There's only 2 possibilities, really. To get a 15, you're going to, if it's positive, then 14 plus 1 is 15. 15 divided by 3. Sorry, 15 divided by 5 is a plus 3. So it could be 14, a plus 14. How would I get a negative 3? I'd have to have a negative 15 on the top. And the only way I'm going to get a negative 15 is if it's a minus 16, because minus 16 plus 1 is minus 15 divided by 5 is a minus 3. So there's your 2 possibilities. So you could have, these are our 2 possible answers. 3x minus 4y minus 16 equal to 0, and 3x minus 4y plus 14 equals 0. Now, why are only these 2 particulars? Because these are the only 2 particular ones which, when you use it with a point on this line, will generate a distance of 3. Any other possible parallel line will not generate a distance of 3. Okay? All right. Leave it at that, and let's see how we get on. Okay, bye.